Yay. Okay. All right, they're doing bell work, and I'm just going to slightly behind, so I'll go ahead and open this up. Move me over here. Dear math, solve your own math problems. All right, anyway, math short for today. Input, say it, everyone. Just to prove that you're here, so this is stupidly easy. 2 times 5 minus 3. Nobody would screw that up. F of C. Well, that's just 2, anyone? 2, anyone? 2, anyone? C, CX? No, it's not multiplication. It's, everyone say this word. And by the way, that's what composition of functions really come down to. It's just a series of substitutions. I believe we did this last year. F of G of F of? Oh, I got yelled at because I was the Math 2 honors teacher last year. And Math 3 honors teachers are mad that we cover all this stuff last year. So I guess we go through this pretty fast. Drink time. 8, right? You don't really need me for that, correct? Now this is where the stuff hits the fan, so to speak. Whenever you're F of ing, what? An expression that's more than just just one variable or one number, and also the same variables in action. So you might want, if you struggled with this last year, I should be able to go through this pretty fast, then get your highlighters out. No one moved. Because that's all that's just a place marker. And I think you guys probably understand this pretty good. I don't know what my honor or regulars will be. Their test is actually Friday on this stuff. We'll find out. But if you understand this, then this will not be a really hard section. All right? If you understand that x is replaced with 5x minus 1, it's like a place marker highlighting. That's the hardest thing you can run into. And then some algebra. I do have some A-Bers that still can't FOIL. Hey, if they can't FOIL, what else can't they do? They can't factor. And that was the whole point of my good FOILers, good factors. Am I right there? People are like talking in the, okay. I thought they were whispering about my mistakes, right? I have many mistakes in life. Like, hey, let's get married. Anyway, whoa. Did I sneak that in the video? Sorry. All right. Anyway, composition of functions. Okay, so here we go. Yeah. So there's two ways of writing this. Number one, hey, you got to know this. This is not a dot. So a dot would mean multiplication, and we could have f times g, which means multiply the two functions. No. I call this fog, all right? That open dot instantly means composition of functions. And really what a composition of functions is really plugging one function into another. And I think that sentence says that up there to some extent. You can go ahead and read. I'm not supposed to be your storyteller. All right, and then our first set of questions are actually pretty simple. And I think we had these last year, but not in this incarnation though. So there's a little minor difference, having to fish around a couple different functions at once. Okay, so anytime I see this kind of question, fog, I write it like this. And then how do I work with double or multiple parentheses inside? Everyone say it. Yeah. That's a PEMDAS thing, right? So it kind of does apply here. And all this is how you verbalize this. Sorry if I have chicken scratch. F of G of X. That's how that is read or said to somebody, verbalized. Okay, so then I do have the inside out thing. And then these questions like A and B, it just means that you evaluate the inside first, but it doesn't apply to C and D. And then use the answer from the inside and plug it into the outside. So really it doesn't really have f of g of s, so I'm not sure what they were saying here. So if I have f of g of a number, what this means is you do the inside first, you find out what this is, g of the number, and then you f that answer, whatever this is. You plug it into the f function. That sounds weird. But anyway, let's move on. I don't know what their language is that they're looking for here in these notes. I should have copied more of their work. All right, so A, B, and C are really simple, all right? And I think you remember this from last year, so I doubt I could almost not be your note person here. I think I could let you go and you'd probably be able to get all these. All right, so G of 3 is what? What's G of 3? What's the answer? What is G of 3? Not 6, but 7. So I plug in 3 here, and I don't really want you to write work. For no purposes, I wrote it all out. 2 times 3 plus 1. So you just ignore this for a second and just evaluate G of 3. Oh, I got that answer. Now I plug that answer into the F function. What's F of 7? What's the answer? 16. You don't get it. 3 times 7 is 21 minus 5. Just tells you where you're directed to go. So G of F of 3, hey, look at these are reversal. So now I have to go to this first. F of 3, 3 plugged in here. 3 times 3 is 9 minus 5 is what? 4. So through watching, I should not have to write these out. I really should, not in this class. All right? And then G of 4, what's 2 times 4 minus, plus 1, sorry. 9. That's what I would need to see from you. But to be honest, this would probably be in the multiple choice portion of your next quiz, which we're going to slide one in right before Thanksgiving. That's a good idea. Otherwise, last year's plan, they had the next test was December 11th. And that's like too much. That's like, remember the homework's like 45 points. And we have a 45-point homework section once. Yeah. You remember that? Too long. Maybe next year we'll break that up. That doesn't bother you, but I think we do have to split those up a little bit more. F of. What a weird question. What's F of 4? What's F of 4? Now I plug in a 4. 12 minus 5 is 7. Well, then now you go back to F and plug in 7. You do that first evaluation and then go back. 3 of 7 is 21. Is that 16 again? Oh, because it was F of 7 over here randomly. Nice. Then the harder, it's not really hard. The harder ones is, what is F of G of X? Well, now it's a progression of, this is the real, and really this is substitution. You did substitution with numerical things. Now you're substituting one function into another. First step is replace G of X with its name. I really highlight this one. And now go to the F function, which is here, and wherever there is an X, replace it with that. That's what I mean about the hardest thing you could run into. Of course, the algebra could be more challenging. How do I do this? For some reason, something happens to students that aren't algebraically sound. They just don't get that. This gets replaced with a 2x plus 1. And then weird questions I get of students that are not, algebraically sound. Where did the F go? Well, where did the G go here? I went to G. I plugged in 3 into the G function, and I got 7. You don't write G next to that. That's just telling you where you go. This is function notation. All right, I don't think you have those problems. I just like talking out loud what weird things I get students thinking about and doing. 3 minus 5 is -2, and you get an expression when you're done. Got it? There is no evaluation because I don't have a number. All right, and then when you switch it, do you get the same thing? Not normally, only in very rare cases. Okay, I can't really highlight this again, so the highlighting doesn't work for this one. So f of x is 3x minus 5. Then you go to the g function. Fine, I can do that. I can plug this into the g function. So I could cheat a little bit, do some highlighting there. All right, so it's 2 times 3x minus 5. Only in the rarest cases when you switch it does it end up being the same thing. 6x minus 10 plus 1 is minus 9. Is everyone okay out there? Okay, now, this is the only kind of questions you haven't seen before, but it ain't no thing. Anyone? Chicken wing. Okay, so you have 3 different ways of expressing a function. A graph. This is a piecewise function. A chart of values. And then this is actually a piecewise function with equations. Or with the pieces in equation format of one graph. Okay, and we've talked about piecewise before. You didn't like that chapter, did you? You didn't like that section. Wasn't that one of the ones you didn't like? Yeah, I hated it because it was new, and I hated it. All right, never mind. Because we didn't do it last year. All right? All right, anyway. All you got to do is this. What's G of 5? Which one's G? The graph, the chart, or the 8? Come on. It's the chart. What does G of 5 say in the chart? What does it become? Input, say it. Output. So you're yanking that output value off of that chart. Then what's f of negative 2? Of course, that's the graph. Negative 2 comma output. What is it? Oh, no. Oh, it is. I'm sorry. Sorry, I thought it was 3. My bad, dog. Okay, when I ever see, I got a little thing in there. Excuse me, let me get some water. I'm glad I did the video. Ready? Cheers. All right, let's go. Let's go. Let's go. Cheers. Crinkle up. Let's go. Come on. Crinkle, crinkle. Crinkle. All right, everyone good? There we go. Hear that? I hope yes. All right. You know, now teaching in America, there has to be a water break every 7 minutes. Otherwise, someone might faint. Okay, it's in their contract. If I don't do that, I could get fired. All right, so I do that. Whenever I see the open circle, what's f of 8? What's f of 8? What's the answer to that? 3, 2, 1, go. Negative 1. It's right here if you're still confused. And then this is h of negative 1. Where's it? Okay. All right, now let's not kid around. Where do I plug this in? Which part of h? First, second, or third part? Which one? It's first. These are the parameters of what you're allowed to plug in. Input, say it. I still got the thing. Might need another water break. We'll hold off for a second. All right, so that becomes negative 7 plus 3 times negative 1. Okay, what does that become on the inside? Negative 10, but what's the answer? 10, that's absolute value. This ain't no thing. Anyone? Oh, yeah, I did that already. Oh, yeah. Is that serious? G of 0? Anyone? What's G of 0? There's nothing. We're not like deriving. Look at it. What the heck is that? So what's G of 0? What do we say? Does not exist. All right. So that's weird. We had something different. That's why I wasn't. I thought these were the exact same notes as the other ones. That's just a little different there. F of, no big deal. So if G of 0 doesn't exist on the chart, then you just say, is everything okay over there? All right. F of 2. What's F of 2? What is F of 2? Okay, and then we had something different. Yeah, so they did change this a little bit. All right. So the BC teachers last year gave us these notes for AB, and I thought they were exacts. Nobody cares. What's F of 1 then? 4. Ain't no thing. Here's 1 comma 4. Yeah, chicken wings again. You know, I've not had chicken wings in a while. I think it's due. All right, where do I plug in h of 1? Top, middle, or bottom of h? Middle. What does that become then? What's g of negative 4? Oh, nice. Delicious. What is it? Pi. Negative 4 comma pi. All right, then h of 5. Let's get this chicanery done. Where do I plug in 5? Top, bottom, or middle? Sorry. Bottom. What is h of 5? Negative 5. F of negative 5. If you're not, it's because you plug in x here, because this is where x is greater than 1. So that's a. Then what's f of negative 5? Where's f? Right here. Oh, no. What is f of negative 5? DNE. We said bogus in, the regular class. Bogus question. That's a word from the 80s when I was cool. All right. And I had a mullet. I actually did have a mullet. And I wore, for my senior picture, a nice little sweater. With does anyone even own a sweater in here? Sweaters? They're not a thing anymore. Yeah, sweaters are a thing? Okay. Are they really? Okay, I don't know. With multicolored. Okay, so now it's equation time. I don't think, but here's the problem. It's this one. This becomes a pain. And there's a little rule that you got to follow here. So first of all, this does not apply to the first 3, because those are not x's. All right, it applies to the second 3. So what I want to do is find the domain of all of these. What's the domain of a line? Almost always, unless it's vertical. What's the domain? All real numbers. I don't think anyone gets confused by this anymore. The APers use that too, right? Double R, double lined R. That's really the notation is this X E R. That's X is an element of real numbers. How many people that's the first time you've seen no? No. Okay, I tricked you. Okay. What's the domain of a parabola? Always. That's what this is, and it does go up. It's all real numbers. Okay, so I'm finding these domains because when we do a composition, I almost said combination. Composition, I almost did it again. You have to worry about domain issues, so it's better to get them up front, and then let's see what happens when we do a composition. All right, what can't you take the square root of in the real world? It gets a little complicated. You know what an I number is, but we're not allowed to have those when we're talking about like graphing something. An I number doesn't go on the graph. So we have to kind of exclude imaginary numbers as existing like right now, or that we can't write an I number. So therefore, what's true is the inside must be positive or 0. So the inside must be greater than or equal to 0. I'm sure you can do this in your head. What does that result in? X is what? Greater than or equal to what? Negative. But I'm sure you could, if you're not fractionally challenged, I'm sure you knew if I took 3 and multiplied it by negative 1/3, I'd get negative 1 plus 1, which is 0. That's the threshold of where this works and doesn't work. So to write that in interval notation, it's wrong. It's bracket negative 1/3 to infinity, right? So that's how we write it in an interval. Then the last one, I will throw this podium if no one knows this answer. What can't X equal? We spent a whole chapter on this. Oh my, and then my don't get me started on the ABers. That's why I had to say throw the podium because I don't get it. And I'm like, we did this for 5 weeks. Anyway, sorry for yelling. By the way, my Wednesday turned out not near as bad as I thought it was going to be. Thanks for asking. All right. You know how I hate my Wednesdays. Wasn't I complaining yesterday about Wednesday already? No, you guys? Maybe it was later. Holy cow, we had a major, what just happened over here? Major fumbles. Oh, I don't know if you heard that on the video. Everyone's okay. Don't worry about it. Okay. All right, so what's M of negative 2? Okay, what is M of negative 2? What's negative 2 plus 1, then 3 divided by that? Anyone listening anymore? Negative 3. And then what's K of negative 3? Come on. Do I really have to do these? Someone said yes. Of course. All right. 9, 14, negative 12, 2, hike. If I was a quarterback, I'd throw negative numbers in there. Anyway, does anyone know what I'm talking about? All right. P of 0. Oh, what's 3 times 0 plus 1 and then square roots? 1. So 3 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. This ain't no thing. And then what do you end up getting there? 3 halves. This is ridiculously easy. Why are you even doing this, Mr. Oh, no, fractions. AB student. No calculator? You're abusing me. What's 1 plus 1? 2, 3. P, if you expect me to do this. All right. Oh, by the way. Oh, no, this doesn't work very nicely. Wow, that's real. Isn't that right? Or did I do this wrong? Oh, I went in the wrong function. Okay, sorry, AB students. I didn't mean to be. Okay. H of 1. 2 times 1. Is that negative 1? And then what's P of negative 1? Oh, no. No, you would say on this one, not real. Isn't that square root of negative 2? So not real. It's not DNE. It exists. It's just not real. But even though you do get negative 2, you kind of write in the answer there. All right. So now, what we got to do in these next ones, and we almost done. Yes, good. And I bet you do pretty well in this, the last part. And yeah, I am going to be done pretty quick here. Okay. h of x. So this one, you insert one. We already talked about that. So that means h of x is, let me not make a mistake on this, 2x minus 3. By the way, I should have wrote this down. Listen, whenever you do a composition, you have to worry about this domain, and then the final answer's domain. And put it all together and make sure that all of those conditions are accounted for. But honestly, what are the domains of h and k? What are the domains of h and k? All real numbers. So what's the composition's domain going to be? All real numbers. We'll play this game, but watch what happens with the last one. All right, and then the next one, we could use the highlighter, but you're kind of limited. I guess I shouldn't have done that. I follow my highlighting here. It would be this is yellow because that's h of x. And I'm going to this function and plugging it in. So sorry, that slid up on me there. So wherever there is an x, I replace it with 2x minus 3. And then good factor, say it's, because I remember last year how many people still couldn't factor for a while. They go, I swear to gosh, if you guys that are still not foiling this, I meant foil, there's a problem. You are doing the same thing over and over and over again wrong if you just square 2x and square negative 3. It's just, you're killing me. If you need to, go like this and write it next to itself. But I don't. I just go like, I know that I visualize that's happening and say, all right, 2x times 2x is 4x squared. I know I do 2x times negative 3 twice, so that's negative 6x twice. And then I know I do negative 3 times negative 3, which is 9. And then this is 8x minus 12. Make sure I don't make any mistakes. Plus 5. And then to make sure this fits in the final answer, 4x squared. I like doing this. Go on. That's minus 4x. And then negative 3 plus 5 is 2 again. Do I have to factor that? No. Okay. And then this is, the domain of this is all real numbers. It did say whenever you do a composition, find the domain's the composition's domain. I can't think of the domain of the composition. That's right. I'm having trouble with my words right now. Okay. All right, k of p of x. Okay, that's a nice little question. I start with p of x. P of x is root. Okay, so right away, does p of x have a domain issue? Yes or no? Yes. So no matter what happens, your composition will have that problem, that domain problem. But it doesn't clear up. But imagine if I didn't have the 4x. Just imagine, because you're in honors, you can handle it. I could actually highlight this yellow and it still works for my highlighting, right? So I'm going to k of x and inserting a different thing. So imagine this middle term wasn't here just for a second. 3x plus 1, square root. And then square. What's a square root squared? What's a square root squared? What happens? Does this word cancel? Would that have a domain issue anymore? No. Guess what, though? It came from a composition of something that did. So no matter what, that domain issue is at least going to be the domain issue of the overall composition. I always had a problem with this. I guess it's just a rule. It's just a rule. It's one of those math semantics. It's one of those math things. Yes. But you know what? It's still there because I have to plug in a 3x plus 1 here. So it's actually a good point to bring up, even though it doesn't happen in the notes. And then this, what's 1 plus 5? What's 1 plus 5? Because someone's going to ask me, looking up and down, where'd you get that 6? And I'll say it one more time. I did 2 things at once because we're in BC. I can't say honors anymore because the AB are honors as well. All right? This squared is 1. 1 plus 5 is 6. Okay, so yeah, that's where we got it from. All right, so there's the answer. And then it says rules. We have to, and there's nothing to do with that. I can't take that roots and combine it with the 3x and the 6. I'm done. So it's just a weird final answer. All right, and then this one's good. Hopefully it's the same as, I literally actually just did this one today because Monday's notes I didn't finish with the regulars. And then Then I had to clean it up today because I forgot yesterday. Whole bunch of stuff going on. So m of 2x minus 3. So by the way, I will have this domain issue no matter what. I don't care what happens. And you'll see what happens. It actually does create a little conundrum here. M of, all right, I guess I could use the same highlighter here because I'm just now moving over to here. I don't know if you want to, no one's highlighting. I think you understand this. 3 over, and then wherever there's an x, you plug in a 2x minus 3. That becomes 2x minus 2. Now, the only reason you would have to factor is if it cancels. If I take out a 2, does it cancel? No. So you don't have to. It's not a rule. And there's no x minus 1 up there. You can see the future, and it's bright. So still the domain, let's write, this does happen. They go back and forth on the way they write domain. So the domain is x such that, and then we already knew x could not equal -1. This is a different way of writing this in AP. Actually, I feel like it's 50-50 on multiple choice questions, whether they do interval notation or like inequality notation. You just got to be able to read both. So I'm going to do that right now. But wait, what else can't x equal? What would give me a 0 in the bottom on this one? 1. So here's what's weird about this. If you didn't hear what I said first, this is not a domain issue for this. So someone might have left that out at the end if they just look at the end. And that's the weird thing about compositions. It's before and after. All issues. All issues. Before and then after, and then write them all. Okay? And then synthesize it into a clean answer that gets them both. This was pretty easy. Okay, and then I think you guys are doing good. And actually, my A-Bers did good. We literally did this one today. You need to understand the directions. So read the directions first. Go ahead. Then the last one's pretty simple and pretty fast. We got less than 5 minutes, but of course I'm doing little delays in between, letting you think. Maybe a little bit more because I'm going to have you come up with the answers. There is some discussion going on, so I just wanted to sit out there for a second. Okay, then I hope in your reading you understand, okay, what they're telling me then is this. This answer right here came from this. So what I have to do as a student is find out what is this and what is this. Did you guys, how many people figured that out? You were reverse engineering to find out what the other two functions are, who I inserted to who in order to come up with that answer. Now I will tell you, listen, there's an infinite amount of answers. It depends how fancy you want to get with your algebra. I mean, I could almost come up with a few. Yeah, I could come up with 2 right now. And actually, I could come up with a third, which is not allowed. Here's what's not allowed. You're a bum. You're a lazy bum if you say this. And I hope I do get some kind of chuckles here to understand how lazy this is. If I said g of x was that, if you understand this concept, then what would f of x have to be? 3, 2, 1, go? No, you're close. A-Ber said that too. Not 1. I need a placeholder. So x. You could do that for every single question like this. And you get it? You get how lazy and bummish this answer is? Okay. So come up with another one. Now, I'll tell you the one that you probably come up with is a 99.9% of the people would say this. All right, but go ahead and think about it. How many people understand that first one? That is technically valid, but you're really doing nothing. You kind of understand that. I mean, you understand the concept, but you're being lazy about it. Okay, ready? Did you guys have an answer? Did you understand the previous one? The bum answer? Well, then you should kind of go with the second one then. Okay, so here's the 99% of what people would do. 99% of the people would just do this, right? What would that mean f of x would have to be? 3, 2, 1, go, x to the 4th. This is 99% of everyone would do this. That's at least not bummish. At least you got some sort of operation going on there. You get it? Well, Good foiler, say it. This ain't foiling. It's the idea of check my answer. If I put 2x plus 3 there, then f of that, I put 2, if I put 2x plus 3, then it's to the fourth, and it turns into that. So here's another one. You ready? Or I'll do this a little bit differently. What if I did this? This is where it gets into how I can have an infinite amount of answers. What if I just said that for g of x? Think about it for a second. And then what would the answer be? Parentheses, go ahead. X plus 3 to the fourth. This is why there's an infinite amount of answers. I could keep going with some crazy stuff. You know, I could just keep going crazy. I could come up with all these different answers. And if you did that, that'd be fine. I would have to make sure your answer does actually work. Because think about what happens. I'd have to put, I'm sorry, you said 3. I think I was doing too many things at once. That's a 3, right? Right. I saw people looking at me, you know. All right, and then x gets replaced with 2x, and then you got that. That's why there's an infinite amount of answers. But I'm going to tell you, most everyone's going to do something like this. If it was multiple choice, it'd be that. Or maybe I would put this and just you'd have to say, yeah, that would work. You know what would be a great answer? Which one doesn't work? And then I have 3 different ones that do. Oh, I just came up with a great idea. I might bring that up with the powers that be. All right, last one. You go ahead and try to get an answer now. More people should be able to get this one. Remember, reading the directions, and that is part of it. Maybe that's where people get things wrong. They don't get what they're being asked. Okay? Well, it is. It definitely is. It's not a shot. Especially all the math language. Now, if you put f of x equals x, anyone? Gone. Do I do that enough? I feel like I don't do that one either. You're gone? Have I said that before? You're like an umpire? I'm an umpire? What other one did I not? Oh, no, I just said, huh? I pointed the door, you're gone? I said something yesterday, you guys, you said I never said it before. That was to wake you up, I think. G of x, what everyone put? 3, 2, 1, go. Most people would put, no, if you put the square root, you're in wrong order. I said g of x. 1 minus x squared. She wants to get this over with. Did you hear? Did you hear the tone in her voice? And then what's this got to be then? Every day. Just leave me alone. All right. Oh. Need to see somebody? No. The drink time? No, let's just get it over with. We'll take a drink after. Okay. Input. What? Did I do something wrong? Oh, yeah. There's other possibilities. What do you want to say? Just tell me. Verbalize. Well, let's 1 plus x. Okay, this is going to be interesting. Go ahead. It would have to be, yes. It would have to be g of x. This is an interesting one. Yeah, just no parentheses. Because that means the square is not in the negative. Yeah, so then, yeah. So there's another infinite set of possibilities. Okay, all right, did you read this one? Did you realize input, say it? Input, say it. So this is essentially changing it in terms of the volume in terms of radius compared to time, right? Because they do have a formula of how the radius changes over time as you're blowing up this balloon. So it really is a S of R of T. It is that's what a composition does, kind of in the real world, if you read the question. And I'm not here to read. We're in honors, we can read. Can we read? All right. 2 over 3t cubed over squared, sorry, not over. Okay, so I replaced that r with this. So it is plugging one function into the other. That's changing the volume in terms of the radius into time based off of the parameters set up in this question. So, all right, just one thing to clean up. I think you guys, oh, we did this whole chapter. Come on. What's t become? T to the third squared, t to the sixth. Okay, and then how do I multiply fractions? I multiply across. Wrong. Multiply across, so that's 16 pi over 9t squared. Sixth. I don't know what's going on. All right, sorry. Saying bad things. All right, bad math words. Okay, that's it. Hasta la vista, baby.